Okay, Year 12, last video of this chapter. We're talking about chemical synthesis or making products. And here's our syllabus point. Draft and construct flowcharts to show reaction pathways for chemical synthesis, including those that involve more than one step. Okay, and here's an example from the textbook. It's like a summary of all the reactions that we've done so far. And in each box, they've given one type of organic compound, and see the arrows? They're pointing to different types and they're showing you and summarizing how to get there. So that's a good chart. So much of organic chemistry involves making a desired chemical compound, and you need to use a series of reactions to get there. So knowing common organic reactions will allow chemists to plan a multi-step synthesis to the product they're looking for. Okay? Mostly, the most common way of doing this is backwards. So taking the final product and simplifying it and working through a series of reactions backwards until you get a simple molecule that you can buy off the shelf. And this process is called retrosynthesis. So synthesis backwards, retro. So here's my example. You want ethanoic acid. Okay. What you can do is, well, you can go, ethanoic acid can be made from the oxidation of a primary alcohol, okay? So ethanoic acid could be made from ethanol. Oh, I don't have any ethanol. How do I make ethanol? Well, I can make ethanol from the hydration of an ethene, I should say, okay? I should change that. So if I had ethene, let's say I could buy that off the shelf. What I know then is working forwards that I can do a hydration reaction to change it to ethanol, and then an oxidation reaction to change it to ethanoic acid. Okay, so it's retrosynthesis, looking at what you want and taking a step backwards until you can get something that's common enough that you have it. Okay, so looking at this particular part of the chart here, we're talking about alkanes, alkenes, and haloalkanes. So you can move between them. So going from alkanes to haloalkanes, substitution, and going from alkenes back to alkanes is addition or hydrogenation, addition of H2. Okay, so we can use the adding, can use, I don't know if this is related to it. Anyway, but I'm talking about the bromine test and stuff like that. Okay, not the best video. We can also use this pathway for testing for several different alcohols. Okay, so primary alcohols and secondary alcohols will decolorize permanganate to produce. Primary alcohols will decolorize permanganate to produce aldehydes and then carboxylic acids. Secondary alcohols will decolorize permanganate to produce ketones. Tertiary alcohols will not react at all. Okay, you can also use dichromate as well. Okay, so you can set up a series of reactions there to determine things. Okay, so here's a reaction pathway with a question in it, past HSC question, and this is the type of thing we're talking about. Okay, so we've got compound X, Y, and Z, and we're starting from petroleum fractions, and it's asking us to identify. Okay, so if you're starting with petroleum fractions and you're doing catalytic cracking, what you're hoping to form is that building block there, okay? Ethene or ethylene, okay? So compound X wouldn't be propene, wouldn't be ethanol, it would be ethylene or ethene. That's what we want there, okay? And if we're dilute sulfuric acid, okay, we're going to add, from memory, an alcohol group across it. So then we're forming ethanol. And so that one's right. Ethylene propanol is not correct. And then we've got an alcohol with propanoic acid, or alcohol with a carboxylic acid and concentrated sulfuric acid. That is an esterification reaction. Okay, so we're going to form alcohol first, so that's ethyl, and then the propanoic acid, propanoate. Okay, So that one there. We're not going to get it around the other way of propyl ethanoate. So this answer is definitely D there. Okay? So using this chart, a product of fermentation was reacted with carboxylic acid. Which of the following organic molecules could be that product? Okay? So a product of fermentation is an alcohol. An alcohol plus a carboxylic acid will give an ester. Okay? Which of the following molecules could be the product? Well, which of the following is an ester? Amide, no. Aldehyde, no. Ketone, no. Ester. So it's propyl ethanoate. Okay. Pentan 2-one was the product of a particular synthesis process. Identify the correct precursors of this product. Okay. Pentan 2-one. So it's a ketone. 5. So it's basically that with hydrogens around it. Okay. So the precursor 2. Okay. So precursor 2 just came before this. So it's saying which of these precursors is the one that gets to the ketone. Okay. So we're talking about an oxidation of an alcohol. Oxidation of primary alcohols will make an aldehyde. We haven't got an aldehyde, we've got a ketone. So we can cross out the pentan 1-ol, and it's the pentan 2-ol which would put the ketone in the 2 position. Okay. All right. So precursor 1, how do we get to pentan 2-ol? Well, we need pentan 2-ene. Oh, that's terrible. I should change it. Pent 2-ene or pent 4-ene. Okay. So we have to have the double bond in the second position, otherwise we'll get it in the end. So it's pentan 2-ene. So the answer's A here. I need to fix up these ands, don't I? That's terrible. Okay. Molecule X was reacted with conc H2SO4 plus heat, which produced molecule Y plus water. Molecule Y was reacted with HCl gas, which produced molecule Z. Analysis showed that molecule Z was chloroethane. Okay? Ethane? Chloro. Okay. What is the identity of molecule X? So we need to work backwards, a retrosynthesis. Okay? So if we're adding HCl to something and we're getting this chloroethane, we must have started off with a double bond like this. Okay? Or just ethene must have been Y and water. Okay? So going back from Y to X, if we did concentrated H2SO4 and heat, we must have done a dehydration reaction because it left water behind. Okay, so X must have been ethanol. Okay, let's check it by going forwards. If we take ethanol and we do concentrated sulfuric acid and heat, we do a dehydration reaction, we get rid of H2O and we're left with ethene. If then we add HCl across the double bond, we end up with chloroethane. Okay, so the identity of molecule X is ethanol C. Oh, another one. Which of the following alkenes would be the best precursor to hydrate and then to oxidize to form pentan 2-one? This is like the question we just did before, didn't we? 2, 3, 4, 5. Okay. Pentan 2-one. So if we oxidize that, it must have come from 2, 3, 4, 5, this alcohol, or pentan 2-ol. And if we hydrated that, it must have come from that one there. Pent 1-ene. Well, you could do it from pent 1-ene. Or pent 2-ene, sorry. Pent 2-ene. Okay. So now you can do chemical synthesis, and there's a little activity there too. And we're at the end of the chapter.